Hello everyone, I am Dr. D.V. Srikanth, Professor, Mechanical Engineering Department, St. Martin's Engineering College. Today I am going to give a lecture on unconventional machining process. In unconventional machining process, abrasive jet machining process. A process where the involvement of tool is not there. Only the material removal takes place by its energy. Energy in its direct form will be acting here for removal of material. Let's go through the process. See, coming to the presentation organization, coming to this introduction, methodology, experimental investigation, nozzle erosion, optimization and CFD analysis of AJM, which we are dealing with. Whereas before going to AJM is the process of unconventional machining, where what is unconventional machining? What is the difference between conventional and unconventional machining? Let us go through that process also. Okay, let us go through that process also. Coming to unconventional machining, a machining which takes place due to the energy in action of the energy in its direct form. What is energy? Energy is of different sources. One is mechanical energy, the other one is electrical energy, third one is thermal energy, and fourth one is electrochemical energy or chemical energy. Different types of energies are used for machining this. That means here in basic mechanical process, a tool is acting on the workpiece for cutting or machining or drilling or boring. But in this process, especially in unconventional machining process, there is no point of tool acting on workpiece for cutting. Okay, now example, air. By using the air, the cutting process will take place, and by using water, the cutting will take place. By using electrolytic solution, the cutting will take place. By using the chemical energy, the machining will take place. Like that, different forms of energy will be acting on a material, a workpiece for cutting, machining or other process. Okay, once we will go, let us go through the process by starting the unconventional machining process. Here, before going to that, what is unconventional machining process? We will go through. Okay, coming to the see, the definition of unconventional machining process varies. Different definitions are there. Coming to the first one, where unconventional machining process is a process, it is called as modern machining process also, where the machining takes place based on the energy. That means the mechanical energy, the thermal energy, electrical energy, chemical energy, or other combinations of all these energies will be acting on the tool workpiece for machining. Like harder and brittle materials can be machined comfortably by using this process, harder and brittle metals. Whereas if you see the other processes, in basic conventional machining processes, the harder and brittle materials are very difficult to machine, but it happens with unconventional machining process. That is only the advantage with unconventional machining process. Coming to the classification of unconventional machining process, there is unconventional machining process, modern machining process, non-traditional machining process. The terminology of these machining process varies in three different forms. Coming to this, non-traditional machining process is subcategorized as mechanical machining process, thermal machining process, chemical and electrochemical machining process. Whereas what is this USM? Ultrasonic machining process. Based on ultrasonic energy, whatever the machining takes place, that comes in ultrasonic machining process. Next, water jet machining process. This is what we call it as water jet machining process. In water jet machining process, water acts as a tool for cutting the work material. The third one is abrasive water jet machining process. This is abrasive jet or abrasive water jet. This deals with abrasive particles, that means small grains, small metal grains, silicon carbide, boron carbide, aluminum oxide, diamond dust. These are all different types of abrasives. Abrasive mixed with water or abrasive mixed with air. Air will be used for machining here. Whereas coming to the thermal energy, electric discharge machining, discharge of electrics. Okay, next, electron beam machining, laser beam machining, and ion beam machining, plasma beam machining. These are all different types of formats available in thermal machining. Whereas chemical machining process, chemical machining, like laser, plasma chemical, electrochemical machining process. These are all the three different types of classifications. Coming to the next one, energy in its mechanical energy. Ultrasonic machining and like ultrasonic machining, water jet machining. What are all used here? Abrasive particles are used. Next here, the cutting will be performed by using the water itself. Okay, whatever the abrasives we are using, based on that abrasives, we are going with abrasive jet machining process. Now, starting what I have explained about abrasive jet machining process, we will go through that process. Coming to the abrasive jet machining process, like different types of materials that can be used in abrasive jet machining process are for machining glass, especially glass. Glass is very like minute. You can't machine glass by using other machining processes, conventional machining processes like lathe machines or automated lathe machines or other things, boring, drilling and all. But by using abrasive jet machining process, glass can be machined comfortably. Ceramics, after that glass, ceramic, next hashed alloy. Hashed alloy is a very fine material where it's combination of nickel, cobalt, chromium, molybdenum, iron, tungsten, magnesium, vanadium, silicon, carbon and other copper and other materials. Totally 13 materials will be involved in this. Whereas the hashed alloy, which is hard and brittle material, can be machined by using this abrasive jet machining process. Whereas if you see the many applications of abrasive air jet machining is limited because the air loss, the pressure loss will take place. For avoiding that pressure loss, we have separate arrangement in the compressor setup that we will be showing in the coming video. Next, coming to the working principle of abrasive jet machining process. The AJM process, a focused stream of abrasive grains. These are all abrasive grains. The focused stream of abrasive grains carried from the high pressure compressor, gas or air, okay, will be striking on the workpiece with very high pressure. Due to the high pressure and the coarseness of the abrasive particles. Here, if you see the abrasive particles, the red one which we have marked here are abrasive particles. Due to the coarseness of the abrasive particles and high pressure of air, the metal removal takes place. If you see the velocity of the abrasive particles will be 150 to 300 meters per second, whereas the standoff distance, that means the machining area to the work surface, the standoff distance between machining area and work surface will be 0.3 to 20 mm based on the material, based on the type of machining we required. Means we will be going for honing, deburring and other processes also by using AJM. That's why we select different types of standoff distance between the tool and work surface. This is what a nozzle and the work surface. These two, the distance between these two can be considered. And here we will be using a tungsten nozzle or sapphire nozzle, which will give maximum life of 20 to 22 hours. Next, coming to the other process. Here, this is the process where air compressor, pressure gauge will be indicating the pressure of the compressed air. And from there to the air filter, which filters the air and removes the minute particles which are all present in the air. From there to dehumidifier, humidity means it will remove the water content in the air, dehumidifier. From there to the pressure gauge, again it will indicate initial pressure gauge reading will be varies from the second pressure gauge reading. Why? Because from here to here, if the air is carrying with from the air filter and the dehumidifier, the air loss will take place. That means automatically the pressure will be decreased here. From there, the pressure regulator to the abrasive mixing chamber, vibrator. This is what we call it as vibrator. Whereas the abrasive particles, because of the vibrator's movement, the abrasive particles are mixed with air. This is also called as mixing chamber. From here, the abrasive particles mixed with air will be going to the nozzle, and from this nozzle, the machining will take place. This is what the standoff distance, as we discussed in the earlier practice. This is what the standoff distance. See, next, coming to the next one, See, this is the setup which we have established in our college. In St. Martin's Engineering College, we have established this setup. See this. Are you finding any difference here? See this. At this particular area, a spark is taking place because the abrasive particles are coarse and hard, which are all striking on the work surface. Once it is striking on the work surface, automatically now there is some erosion. Because of the erosion, these sparks will be taking place. Okay, and this is the nozzle which we have designed, our own students, and we have designed, and this is tungsten coating, whereas this is tungsten one, and this is copper coated. These are all the nozzles. This is pressure gauge, pressure regulator, and compressor. These are all the different parts involved in this. Next, coming to this variables and ranges of abrasive jet machining process, like different types of abrasives. As I said before, aluminum oxide, Al2O3, silicon carbide, boron carbide, diamond dust. These are all expensive. That's why I have not mentioned here. Anyway, flow rate of the abrasive particles will be 3.5 to 5.5 grams per minute, and pressure 4 to 8 kg per centimeter square. Whereas velocity, as we discussed earlier, it is 150 to 300 meters per minute. And nozzle diameter varies based on the machining process, as we discussed earlier. It is 1 to 3 mm. And material of the nozzle is tungsten carbide, sapphire, high carbon, high chromium. But in majority of applications, tungsten carbide and sapphire nozzles are used. Next, nozzle life 20 to 300 hours based on the machining process which you are performing, based on the material which you are using. It varies. Next, standoff distance. As I said, the distance between the tool and workpiece, it will be varies from 0.3 to 20, but here in nominal ways it will be 6 to 20. Here if you see, these are all different types of abrasive powders, abrasive particles. These are, it will be looks like powder, but once if it is comes with air, acts as with high pressure, then it acts like a cutter, acts like a tool. It cuts the material, like aluminum oxide, silicon carbide, glass beads, dolomite, sodium bicarbonate, diamond dust, all these different types of abrasive particles which we will be using in the present applications. Next, see, on abrasive jet machining, there are so many like processes which they have performed, like parameters. On parameters researches they have conducted on kerf. Coming to the kerf, let me discuss about the kerf. Yes, we know about metal removal rate, and we are not aware of like coming to the kerf. Kerf is nothing but see, like from here a nozzle, which will be of, this is what the nozzle is. Here the nozzle, from here the particles, abrasive particles mixed with air will be coming and striking on the work surface. Due to the abrasive plus air mixer, due to the abrasive and air mixer, the metal removal takes place. Once the metal is removing, there is the variation of machining. Machining will take place. It is top surface diameter and bottom surface diameter. The variation between the top surface and bottom surface diameter is called as kerf. Here, the variation between top surface diameter and bottom surface diameter is called as kerf. Okay, coming to this kerf, how it will be varies. We will go through a presentation and we will go through that presentation again. Okay, here for finding the MRR, metal removal rate, we have a equation, separate equation which is mentioned here. You can see the by using different parameters, density of abrasive particles, the pressure of the air, and after that the stress flow rate. If you see this, this is what we call the stress flow rate, and after that constant value which is of 1.3. Based on this, the metal removal rate can be performed. Or else the other process of performing the metal removal rate, which is not formulatics, it is a basic methodology where we will be using is, that is, initial weight of the work surface and final weight of the workpiece. By measuring that two, the metal removal rate can be found. But that is a common process where a layman can be performed. But as an engineer, this is what, for mechanical engineer, this is what the formula which we will be preparing. And for optimizing, that means the value which we are performing, which we are getting, how we can optimize that. For optimizing, we will be using different techniques like gray relation analysis, fuzzy logics, and other techniques where we will be used for application. And coming to the materials, as we discussed earlier, different types of materials: glass, ceramic, composites, hash alloys. These are all some materials we can perform. Apart from these materials, we can go through other materials also, like steels, different types of steels, high copper, high chromium steels, mild steels, and if you go through the other process, metals and non-metals also can be machined by using this. Like copper also we have tested. Like we can, normal terminology you can see here: abrasive rate, nozzle diameter, air pressure, standoff distance, AFR, abrasive flow rate. These are all the parameters which we will be using in abrasive jet machining process. Like see, these are all the experimental results of different parameters. The variation of pressure, what will be the MRR of glass, ceramic, FRP, fiber reinforced plastics. After that, hash alloys. Next, coming to the kerf, the variation of kerf. These are all some tables which we are indicating. Next, coming to the other process, see the graphs. How the variation of pressure takes place. Suppose if the glass is machined, machined by using abrasive jet machining process, how the metal removal will take place. See, the pressure at 3 kg per centimeter square pressure, the metal removal rate is 0.02 grams per minute, whereas grams per second. Whereas if you see, once the pressure is increased to 8, automatically the graph is increased. That means by increase in pressure, the metal removal will be increased. That is what basic concept of this process. By increasing pressure of abrasive particles, the metal removal rate increases. Like that, if you see for ceramics, if you see for FRP, see green color shows FRP. If you see for hash alloy, this one violet color will be shown for hash alloy, the variation. But it is not, the graph won't be straight for everything. See, it varies. If you go to SOD, yeah, what is SOD? Standoff distance between a tool and a work surface. Standoff distance between a tool and work surface. See here, here from 2, it start increasing. But whereas at a particular point, a stagnant point, 8. After 8, if standoff distance, suppose up to this point, the whatever the abrasive flow is there, that will be okay. But if it is increased, automatically the abrasive particles will be spreading on the work surface and the machining won't be perfect. See, that's what shows here. Not only in glass, ceramic, FRP and hash alloy. It's a common process. Whereas abrasive flow rate, up to certain point it increases, drastically it decreases. You can see this. And coming to nozzle diameter versus MRR, metal removal rate. That is also, the graph indicates clearly, nozzle diameter. Like this, even kerf, pressure versus kerf, SOD versus kerf, AFR versus kerf, nozzle diameter versus kerf. These are all the observations which we can, by increasing pressure, the metal removal rate increases. It is also observed that by increasing pressure, the width of cut, that is curve. The width of cut is nothing but the curve will also be increases. But the accuracy, whatever the accuracy is precision. It's not concerned with precision, first accuracy. The accuracy of the hole also will be varies. It won't be not that perfect. See, these are all some materials which we have performed in our labs and our students are tested. Means we made our students to test. See here, the hole, drilling of the hole on glass sheet, drilling of the hole on hashed alloy. See, these are all the nozzles. This is FRP. This is FRP, machining of the FRP. This is ceramic, machining of the ceramic. These are all the variations which we have observed. It is not like that student is only, we will be teaching a subject to student. No, practical knowledge by machining, by making a machine and making students to understand about the machining process. Here, this is what the example of that. Here, what we are doing, we are making the student to perform own experiments on a machine where other colleges are not made and other areas it's not performed. See, it's a live example. You can see all the machined parameters. Nickel is machined, titanium is machined. And coming to the nozzle erosion. Nozzle erosion is a very important topic in abrasive jet machining because based on the nozzle only the machining will be, nozzle plays vital role in machining process. Very important role. See here, the nozzles, different types of nozzles, how it will be. Sapphire nozzle, which we made available in the college, sapphire nozzle. After that, different types of nozzle diameters, drilling of glass by using the nozzles, and these are all the different segments of nozzles which we made available in the college. See here, abrasive particles, nozzle, specimen, how it will be. Cause and effect diagram, which we are indicating with the cause and effect diagram. Coming to the cause, nozzle, abrasive particles, nozzle, specimen, pressure, diameter and SOD. Finally, what happens with all these things? Silicon, aluminum oxide, after that pressure is of 6 bar and 8 bar, diameter of this nozzle 2, 3, 4. After that, different types of nozzle materials, tungsten carbide, high carbon, high chromium. After that, specimen, composites, materials, SOD, standoff distance between a two-line work surface. 6, 8, 10. The variation of this finally tends to the effect, which is the effect is nozzle erosion. This is what the cause and effect diagram, which clearly shows that. And see the erosion, how it takes place. This is also practically tested and kept here available for the student reference and other things. How it will be varies. See, initial stage, once if diameter of the nozzle is at 2 and total erosion 0.13. If the diameter of the nozzle is 4, the nozzle erosion is 0.10. That means diameter reduces, nozzle erosion increases. That is what the basic reduced nozzle erosion. That's what the basic components means. Like at pressure 8 bar. Here it is at 6 bar. It is at 8 bar. The variations here. The graph also clearly indicates which one. High carbon, high chromium steel, drastically the nozzle erosion will take place. That means damage of the nozzle will be taking place very frequently. Replacing of nozzle is required frequently. But whereas if you see tungsten carbide or if you see sapphire, there is a variation. It is not like a same comparing with high carbon, high chromium steel. That is the reason why the sapphire and tungsten carbide are much preferable nozzles. Okay, these are all the observations which we have observed while performing the experimentation. And these are all optimization techniques, which we have used, but that is not required. Apart from like as I said, apart from abrasive jet mission, the other processes also used. What are all the other processes? Now let's go to the video of abrasive jet machining, because a basic video, animated videos are available in the net. Not only net, if you see, realistic videos are available with me, but that we will be showing in the next video. Whereas coming to this animated, because better understanding, we will be going with the animated video. You can see this. gas supply, the tank which we are using, basic components, them like filter, air filter, as I have shown earlier, pressure gauge, mixing chamber, vibrator, foot control valve, nozzle. See here, workspace. Like this is what the nozzle, this is what the container, where from here the gas will be supplied. Gas, different types of gas, nitrogen, air, and other gases are used. But air is a familiar gas where we can use comfortably without any cost. It is available. Here, from here, the air will be entering. It will be filtered here, pressure gauge. From there, the mixing chamber where the abrasive particles, the powder supply is nothing but abrasive particles. Abrasive particles will be mixed with the air, and from there, means it will be moved here through vibrator. Once it moves from here, it will be through foot control valve, it will be going to the nozzle, from there to the work surface. Work surface will be placed on a fixture. This is what the process of abrasive jet machining, where see the flow of abrasives, how it will be going from here to air mixed with abrasive will be coming here, abrasive mixed with air, and it will be going to the workpiece. This is what the process of abrasive jet machining. Whereas not only abrasive jet machining, if you go through the other processes of unconventional machining like ultrasonic machining, due to the like abrasive particles only, the ultrasonic means, and electric discharge machining. If you go through electric discharge machining, the discharge, due to the discharge of electrons, when the potential difference between the tool and workpiece is sufficiently high, in EDM, what I am telling about, a spark will be produced and it removes a small amount of material. That means electrolytic action, it takes place in electric discharge machining. Like electron beam of electrons will be passing, like ion separation. Due to that, the electron beam machining will take place. Due to the laser action, laser beam machining, and chemical action, chemical machining, electrochemical action, electrochemical machining, like the different types of unconventional machining processes, which are all used in now day-to-day life, especially if you see EDM, and if you see the EDM, and if you see the other process, water jet machining and abrasive water jet machining, these are all like having many applications in the industry. Whereas if you see the other processes like abrasive jet machining process, there is, because researchers are not focused on that. But here we are focusing on the areas where a particular researchers are not focused. We are researching that and we are educating our students in a better way. See, this is what the abrasive jet machining process. As of now, if you see the researches, the publications, and other journals and other articles, review articles, research articles, very less works are done. But we are making our students to write papers and means submit in famous journals like Scoopus, Elsewhere, Springer, and other sort of journals. And from there, we are making our students to be better in the society, be as a best engineer. That's what our motto is. Like, thanks for giving this opportunity. Like, thank you very much.